Now that we know what the graph of a basic exponential function looks like, that is, a graph of y is equal to b to the x, we can apply what we've learned about transformations of functions to graph transformations and reflections of exponential functions. Keep in mind that any movement in the vertical direction, that is, moving up or down, will impact the horizontal asymptote that is originally at y equals 0. So let me just remind you of the transformations we've studied. If we have a function y equals b to the x, that is f of x equals b to the x, recall that y equals f of x minus h, which in this function would be b to the x minus h, is a graph of f shifted right h units if h is positive, and it's shifted left h units if h is negative. The graph of y equals f of x plus k, which is b to the x plus k, is the graph of f shifted up k units if k is greater than 0, and down k units if k is less than 0. And then the graph of y equals a times f of x, that is, we have this multiplier, which in this case would be a times b to the x, is the graph of f vertically stretched by a factor of a if a is greater than 1, and vertically shrunk by a factor of a if a is between 0 and 1. Then recall also that y equals f of negative x, that is an inside change, that is, we're taking the opposite of x, which in this case would be b to the negative x, is a graph of f reflected across the y-axis, and we've already seen that when we compare the graph of y is equal to 2 to the x and y is equal to 1/2 to the x, because we saw earlier that's really 2 to the negative x. So those are graphs which are reflected across the y-axis. And then the graph of y equals negative f of x, which is negative b to the x, is a graph of f reflected across the x-axis. So in that case, the negative is on the outside, so we're taking the opposite of the y values, which occur across the x. So these are things that we saw in section 11. We're just going to apply them to the basic exponential. So remember those 7 basic graphs, we're just adding another one, which is b to the x, that we can perform transformations on. In this example, we want to graph the function, and we're going to state the domain, range, asymptotes, and identify where the point 0, 1 moves through the transformation. The function we want to graph is f of x equals 2 to the x minus 1. So this is a transformation of y is equal to 2 to the x, and because the change occurs to the variable x, this is going to be a shifting left or right. And in this case, remember, we can set that x minus 1 equal to 0 to find that we get x equals 1. So this is going to shift the graph of 2 to the x right 1 unit. And so I have on the screen the basic graph of 2 to the x, which recall goes through negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, and 2, 4. So it is that basic increasing exponential function. We have a horizontal asymptote at y equals 0. So on the transformed graph, we will move each of these points to the right 1 unit. So 2, 4, when I move it right 1 unit, becomes 3, 4. 1, 2 moved right is at 2, 2. 0, 1 moved right is at 1, 1. Negative 1, 1/2 moved right 1 unit is at 0, 1/2. And negative 2, 1/4 moved right 1 unit is at negative 1, 1/4. And so what about the horizontal asymptote? Well, that stays in place because when we shift a horizontal line right 1 unit, its placement doesn't change. It is still y equals 0. When we draw the graph through these points, we get that basic exponential function, which is just shifted right 1 unit. Does this impact the domain? No. The domain of any exponential function will be all real numbers, negative infinity to infinity. The range has not been impacted because we did not shift up or down, so the range is still everything above the horizontal line y equals 0, which will be above 0 or 0 to infinity with an open parentheses. And where did the key point 0, 1 move? Well, 0, 1 through that transformation moved to 1, 1. Now we want to look at the graph of f of x equals 2 to the x plus 1. So now this 1 is what I call on the outside of the function, right? That basic 2 to the x didn't get changed. We're adding 1. So this will be a transformation of y equals 2 to the x shifted, do you remember? Up 1 unit. So again, we have this graph of y equals 2 to the x on the screen. It goes through 2, 4, 1, 2, 0, 1, negative 1, 1 half, negative 2, 1 fourth. So what I want to do through this transformation is take each of those points and move them up 1 unit. So the x coordinate stays the same, the y value will increase by 1. So 2, 4 will go to 2, 5. 1, 2 will go to 1, 3. 0, 1 goes to 0, 2. Negative 1, 1 half will go to negative 1, 3 halves. Negative 2, 1 fourth will go to negative 2, 5 fourths, right? When we add 1 to 1 fourth, that's really 4 fourths plus 1 fourth, which is 5 fourths. Now what about the horizontal asymptote? I'm shifting this horizontal line up 1 unit, so it actually has to move. It's no longer at y equals 0. It will be at y equals 1. So I can draw the graph of this exponential function through these points, understanding that I'm never going to touch the line y equals 1, and I'll never go below that line either. So the domain of this function is still all real numbers, negative infinity to infinity. Now the range has been impacted, right? We did something to the y values. We shifted all the y values up 1 unit. So now our graph is all above the line y equals 1, which means all the y values are greater than 1. That is from 1 to infinity. And what about the key point? The key point of 0, 1, when we shifted it up 1, moved to 0, 2. And then also just note that our horizontal asymptote, which I've already stated, is the line y equals 1. Now, of course, all of these I could put onto my calculator and see the actual graph, but I want you to be able to look at the function and identify what the transformation is and at least have a general idea of what the new resulting graph will look like. And then one more example here, we have f of x equals 2 to the negative x minus 4. So there are two transformations that will occur in this particular problem. 2 to the negative x, so we have a negative on the inside. So that is, we're taking the opposite of x. But the opposite of x occurs across where? It occurs across the y-axis. So this will be a reflection across the y-axis. And then the negative 4 suggests that we will move down 4 units. So again, I have this basic graph of y is equal to 2 to the x on the screen. Again, that goes through 2, 4, 1, 2, 0, 1, negative 1, 1/2, and negative 2, 1/4. So what will be the change here? We're impacting both the x and the y coordinates here. We need to take the opposite of x and decrease y by 4. So the point 2, 4, if we take the opposite of x, will take us to negative 2. If we decrease the y value by 4, 4 minus 4 is 0. So 2, 4 would flip over to negative 2, 4, and then down 4, which is at negative 2, 0. 1, 2 will do what? It will flip over to negative 1, 2, but then I need to decrease the y value by 4. 2 minus 4 is negative 2. Zero, 1 will not reflect anywhere because it's actually on the y-axis, so the opposite of 0 is still 0. But when I take 4 from the y value, 1 minus 4 is negative 3. Negative 1, 1/2. I take the opposite of the x value, which is positive 1. And then I have to decrease 1/2 by 4. So 1/2 minus 4. If you think about this as to get a common denominator of 2. 4 over 1 is really 8 over 2, right? And so 1/2 minus 8/2 is negative 7/2. So this will move to the point 1, negative 7/2. And then the point negative 2, 1/4, take the opposite of the x, which is 2, and then decrease 1/4 by 4. So 1/4 minus 4 is really 1/4 minus 16/4, which is a negative 15/4, which is right, really negative 3 and 3/4. So this would be 2 and negative 3 and 3/4. And then what about our asymptote? We have this line y equals 0. If we flip it over the y-axis, it stays at y equals 0. But then we need to shift it down 4 units. And so it will become y equals negative 4. And now here we are going to have a graph that is decreasing through these points, negative 2, 0, negative 1, negative 2, 0, negative 3, and through those other 2 points that approach this line y equals negative 4. So what is my domain? Still all real numbers for any exponential function, negative infinity to infinity. Now the range again has been impacted because I shifted this graph down 4 units. That is, shifted the original graph down 4. So everything is above the negative 4. So my graph or range is parentheses negative 4 to infinity. And the key point of 0, 1 through this transformation moved to 0, negative 3. And my horizontal asymptote, which we've talked about, is y equals negative 4.